press the bell icon on the YouTube app and never miss another update.
Now we are discussing about first PUC physics chapter oscillation. So far we have completed that chapter. Now we are going to discuss some numerical problems on oscillation. Now to solve numerical problems in physics, the essential things are formulae, concept, skill and application, right? Now the one of the important thing in solving the numerical problems are formulas. Now we will take that list of formulae that comes in the chapter oscillation. Now the first one will take the relation between period and frequency. So T is equal to 1 by F and F is equal to 1 by T. Now along with the formula you should know the terms what we have used in here. Number 2, we have angular velocity, right? Angular velocity, right? Omega is equal to theta by t. This is also equal to 2 pi by t. This is also equal to 2 pi f. So angular velocity is expressed by omega is equal to theta by t, omega is equal to 2 pi by t and omega is equal to 2 pi f, where t is capital T is time period of simple harmonic motion and f is frequency of simple harmonic motion. And the third one is, that is equation of simple harmonic motion. So A, we can write y is equal to a sin omega t, right? Or with initial phase y is equal to a sin omega t plus phi, where phi is called epoch or initial phase. When initial phase phi is equal to 0, the equation takes the form y is equal to a sin omega t, or x is equal to a cos omega t, or x is equal to a cos omega t plus phi. Again phi is the phase difference, initial phase of simple harmonic motion. And the third one we are having, right, fourth one, in fact we have velocity of simple harmonic motion. So A, this is V is equal to dy by dt, that is equal to d by dt of right a sin omega t plus phi, right? Or we can show that V is equal to omega into square root of a square minus y square, where omega is angular velocity which is equal to 2 pi by t or 2 pi f, right? And a is amplitude and y is displacement at any instant of time, right? And we have C, velocity maximum, right? The velocity is maximum at mean position. At mean position y is equal to 0, then the expression becomes omega into a, right? Where omega is angular velocity and a is amplitude. Now the fifth one, we are having acceleration of simple harmonic motion. Acceleration of simple harmonic motion. We have acceleration A is equal to dv by dt, that is equal to d square y by dt square, and B acceleration A that I am taking, magnitude of acceleration, it is omega square into y. Generally, while solving the numerical problems, we neglect the negative sign because that indicates acceleration is always directed towards the mean position. Now see the maximum value of acceleration, A maximum, acceleration is maximum at extreme position. At extreme position, y is equal to A, this is omega square into A. That is the three formulas. Generally important is A is equal to omega square y, A maximum is equal to omega square into A. Now that sixth one, so period of simple harmonic motion, it is in general. So T is equal to 2 pi into square root of m by k. Now frequency of simple harmonic motion, F is equal to 1 by 2 pi into square root of k by m. Now the seventh one, we are having period of simple pendulum, F is equal to T is equal to 2 pi into square root of L by G, and frequency F is equal to 1 by 2 pi into square root of G by L. Now eighth one, energy of simple harmonic motion. A kinetic energy, Ek is equal to half mv square, or Ek is equal to half m omega square into a square minus y square. It is the kinetic energy of simple harmonic motion. Now B, potential energy, EP is equal to half m omega square into y square. C, total energy, the total energy E is equal to potential energy plus kinetic energy, or this E is equal to half m omega square into a square, So generally these are all the formulae we are going to use here, So while solving the numerical problems in oscillation, you should know these formulas. Mainly remember period, frequency, angular velocity, equation of simple harmonic motion, velocity, acceleration, period, frequency and energy. These are all the main concept in oscillation. Now we will take numerical problems. I will take numerical problems. We will take it one by one. Now I will write it on the board problem, then we will solve it. Now numerical problem number 1 we are having, right. A simple harmonic motion is represented by x is equal to 0.34 cos 3000 t plus 0.74, right, where x and t are in millimeter and second. Respectively. Now determine number 1 amplitude, number 2 frequency, and number 3 angular velocity. Now this is the numerical problem, right? So once again I will read it. A simple harmonic motion is represented by x is equal to 0.34 cos 3000 t plus 0.74, where the x is the displacement which is in millimeter, t is the time in second respectively, right? So we need to find amplitude, frequency, angular velocity. Now let us collect given data. What are the data given in the problem, right? So we have given x is equal to 0.34, right, cos 3000 t plus 0.74, right. It is an equation of simple harmonic motion, right. Now we will take it as equation 1. Next thing is, what are the quantities, right, to be calculated. So number 1, we need to find A is equal to what? Amplitude of simple harmonic motion. Number 2, frequency, take straight away. F is equal to what? And number 3, this angular velocity, omega is equal to what? Now we have standard equation, right? Standard equation, right, is now x is equal to a cos omega t plus phi. Let us take it as equation 2. So we have given equation 1 and we know that standard equation of simple harmonic motion, right. Now comparing equations 1 and 2. Comparing equations 1 and 2, right. See here we have x a here. Now this is 0.34, right? So now again cos. In place of omega we are having 3000. In place of 5 we are having 0.74. That means amplitude is equal to 0.34. But while writing the value of a physical quantity, it is important to note that you have to write the unit. So without the unit, now it will not give any exact right amount or quantity. So x is displacement expressed in millimeter. Amplitude is also the maximum displacement from its mean position. Therefore, it is also expressed in millimeter, right? If you just write it 0.34, then it will not give the complete information, right? Now, again, here comparing this omega, angular velocity omega is equal to 3000, right? And now since time is in second, this is radian per second. So we got A and omega. Now we need to find frequency. We have omega is equal to 2 pi f, or f is equal to omega by 2 pi, that is equal to 3000 divided by 2 pi, or frequency is equal to 1500 by pi. What is its unit? Unit is the hertz. Hertz is the unit of frequency, right? So first read out the problem, note down the given data, what are the physical quantities to be calculated, and apply the formula, right? So to solve the numerical problems, we should know formulae as well as related concept. Now we will take the second problem, problem number 2, right? The time period of a body executing simple harmonic motion is 2 seconds. Now, after how much time interval from t is equal to 0 will its displacement be half the amplitude, half the amplitude. So this is the problem. Let us read the problem once again. The time period of a body executing simple harmonic motion is 2 seconds. Now after how much time interval from t is equal to 0 will its displacement be half the amplitude? Now the given data here, period of oscillation is given, t is equal to 2 seconds, right? Now what we need to find? We need to find the time interval t is equal to what? At which, right, the displacement of the particle is half of the amplitude, where capital A represents the amplitude of simple harmonic motion, right? So capital T is given, y is equal to a by 2, we need to find the value of time t. Now we have this equation, y is equal to a sin omega t. We have that equation, y is equal to a sin omega t. Now this equation can also be written as y is equal to a sin 2 pi by t into t, because omega is equal to 2 pi by t. I have written this equation in this form because we have given the time period. Now this is the displacement at any instant of time t. We need to find what is the value of this t when y is equal to a by 2. Substitute the value of y, that a by 2 is equal to a sin 2 pi by 2, that is t is equal to 2 seconds, into t. Here 2 get cancel. Now we have a get cancel, right? We have half is equal to sin pi into t. But we know that, so from trigonometry, right, now half is equal to, right, that means 0.5 is equal to sin 30 degree, or it is equal to sin pi by 6. 30 degree in terms of pi radian, it is pi by 6 radian. Therefore half is equal to sin pi by 6. Therefore we can write sin pi by 6 is equal to sin pi t. Now comparing these two equations, we have pi by 6 is equal to pi into t. So pi get cancelled, therefore t is equal to 1 by 6 second. So after a time interval of 1 by 6th second from time t is equal to 0, the displacement is equal to half of the amplitude. Is that clear? So once again you see it, we have taken the given data and we have collected what are the quantities to be calculated, and using the related equations we have calculated the required quantity, right? Now let us take up problem number 3. In what time after its motion begins will a particle oscillating according to the equation, right, y is equal to 7 sin 0.5 pi t moves from the mean position to maximum displacement. Now we see here, in what time after its motion begins will a particle oscillating according to the equation y is equal to 7 sin 0.5 t moves from mean position to the maximum displacement. Right, now here given data, we have given that equation. Now y is equal to 7 sin 0.5 pi t. Let us take it as equation 1. In problem number 1, in that problem units are mentioned, x in millimeter, t in second. Here units are not mentioned. Here generally y it is in displacement, of course in SI system meter, 7, right, and time t again in second. Now this is the given equation. Now what is to be calculated? In what time after its motion begins will a particle oscillating according to the equation moves from mean position to maximum displacement? That means we need to find time taken t is equal to what? Right, for y is equal to 0, that is at displacement, to y is equal to a, right, maximum displacement is equal to amplitude a, right. So now we need to find the value of a here, that is what is the amplitude. Now we have standard equation, y is equal to a sin omega t, equation 2. Now comparing 1 and 2, we have amplitude a is equal to 7 meter. Amplitude a is equal to 7 meter. Now again taking the equation 1 in place, right. Now y is equal to 7. 7 is equal to 7 sin 0.5 pi t. The 7 get cancelled, or sin 0.5 pi t is equal to 1. Now, so we can apply the same procedure to find the value of t that what we adopted in the previous problem, right. Now here this is equal to 1 and we know that right, sine 90 degree is equal to sine pi by 2 is equal to 1. Therefore, this equation can be written as sine 0.5 pi t is equal to sine pi by 2. So comparing on both sides, 0.5 pi t is equal to pi by 2. So pi get cancel. So t is equal to, right, now the pi get cancel here. Now t is equal to, right, 1 by 2 into 0.5. 0.5 into 2 is equal to 1. 1 by 1, it is equal to 1 second. So the time taken to reach the maximum displacement is 1 second. Then, just for curiosity, what is the time period of this oscillation in the given problem? Obviously, this is the time t 1 second, it is equal to t by 4. That is 1/4 of the time period, right, taken to reach the maximum value. Obviously, t by 4 is equal to 1 second and t is equal to 4 second. Then what is its frequency? F is equal to 1 by t, that is 1 by 4, that is equal to 0.25 hertz. So in this way we can analyze this problem, right? So in this problem we can get so many information about the simple harmonic motion, right? That means we got the time, we can calculate the time period, we can calculate the frequency, we can calculate the right angular velocity omega, because we know that omega is equal to 2 pi by t or omega is equal to 2 pi f, right? Now we will take problem number 4. Fourth problem, right. A particle executing simple harmonic motion has a maximum displacement of 4 centimeter, and its acceleration at a distance of 1 centimeter from the mean position is 3 centimeter per second square. What will be its velocity at a distance of 2 centimeter from its mean position. Right. Now, once again, I will read this problem. A particle executing simple harmonic motion has a maximum displacement of 4 centimeter and its acceleration at a distance of 1 centimeter from the mean position is 3 centimeter per second square. What will be its velocity at a distance of 2 centimeter from its mean position? Now, we have given data. Right. What are the given? A particle executing simple harmonic motion has a maximum displacement of 4 centimeter. What is the maximum displacement of a simple harmonic motion? That is amplitude. So, we have given amplitude A is equal to 4 centimeter. Again, the acceleration of the particle is 3 centimeter per second square, right, at a distance of 1 centimeter, and acceleration is equal to 3 centimeter per second square at a displacement y is equal to 1 centimeter. These are all the data given. Amplitude is 4 centimeter, acceleration of simple harmonic motion is 3 centimeter per second square when displacement is 1 centimeter. What we need to find? We need to find velocity v is equal to what at the displacement y is equal to 2 centimeter. Now, we need to find what? Velocity at displacement y is equal to 2 centimeter using the data amplitude acceleration at 1 centimeter. Now basically we have this formula v is equal to omega into square root of a square minus y square, where v is velocity, omega is angular velocity, a is amplitude, y is displacement. So we need to find v is equal to what? So in this formula, the value of y is 2 centimeter. The value of a is 4 centimeter. Then what we need here? We need to find angular velocity, right? So it is not given straight away. We need to find angular velocity, right? Omega is equal to what? Right. That means it is not at all a simple problem. We need to apply our mind here. Now, how to find omega, angular velocity? Now, acceleration is given. We have acceleration A is equal to omega square into y, or omega square is equal to a by y, that is 3 by 1, that is equal to 3, the value is 3, or omega is equal to root 3 radian per second, right. So we got the value of omega, that is the angular velocity. Now, this omega is substituted in this equation. Again, taking that equation, v is equal to omega into square root of a square minus y square. Now, v is equal to, this is root 3 into square root of amplitude. It is 4 square minus 2 square, that is equal to root 3 into, right, 4 square 16 minus, that is 4, that is 10, root 3 into root 10, right, that velocity comes out to be 6 centimeter per second. You calculate that, velocity comes out to be 6 centimeter, right, per second. Now, we'll take another problem, that is the problem number 5. Right. A body of mass 1 kg is executing simple harmonic motion, is given by x is equal to 6.0 cos 100t plus pi by 4 centimeter. Determine kinetic energy of the body, right. Now, the problem is a body of mass 1 kg is executing simple harmonic motion given by x is equal to 6.0 cos 100 pi t plus pi by 4 centimeter. Now determine kinetic energy of the body. Now we need to find the kinetic energy of the body, right. In fact, this is maximum kinetic energy of the body, right. Now we have given data. So mass of the body m is equal to 1 kg, given equation x is equal to 6.0 cos 100 t plus pi by 4 centimeter. We'll take it as equation number 1. Now what we need to find is maximum kinetic energy of the body. So V maximum is equal to what? Right. Now we have V maximum is equal to omega into A. While finding A and omega, we can find V maximum. And kinetic energy maximum becomes a half m V maximum square. So we need to find V maximum. For that we need to find omega and A. How to find omega and A? This equation of simple harmonic motion, it gives all information about the simple harmonic motion. That means it gives information about amplitude, right, time period, frequency, etc. Right. Now using standard equation, now x is equal to A cos omega t plus pi by 4. Take it as equation number 2. Now so comparing equations 1 and 2. Comparing equations 1 and 2, we have amplitude A is equal to 6.0 centimeter. Amplitude A is equal to 6.0 centimeter, right? Because the displacement is given in centimeter, and this is equal to 0.060 meter. Because the amplitude in centimeter, but the mass is given in kg. There are two units used, systems used here. One is SI system and one is CGS system. But when we calculate the final quantity, we need all related physical quantities in the same unit. Therefore, I have converted that 6 centimeter into meter, that is 0.060 meter. Now again this omega is equal to 100 radian per second. Now we see it, we have velocity maximum is equal to omega into A, and that is equal to, right, omega into A, right. Therefore kinetic energy maximum is equal to half m V maximum square, or Ek maximum is equal to half m into, right, omega into A whole square. That is if I will take it here, okay. So Ek maximum is equal to, that is half into 1 into omega, that is 100 into 0.06 whole square, that comes out to be, right, 18 joule. You calculate it, the value comes out to be 18 joule, right. Now this is the problem number 5. Now, take problem number 6. A particle executes simple harmonic motion of amplitude A at what distance from the mean position its kinetic energy right is equal to its potential energy. Right. Now once again let us read this problem. A particle executes simple harmonic motion of amplitude A right, at what distance from the mean position its kinetic energy is equal to its potential energy, right. Now we have given data. So amplitude of the particle is equal to A is given. Now we need to find the displacement of the particle y is equal to what, at which, right, its kinetic energy is equal to potential energy, that is Ek is equal to Ep. We know that when a particle is executing simple harmonic motion, the total energy remains same, but the kinetic energy and potential energy changes. We know that according to law of conservation of energy, energy can neither be created nor be destroyed. It can be changed from one form into another form. At mean position, kinetic energy is maximum, potential energy is 0. At extreme position, potential energy is maximum, kinetic energy is 0. That means as it moves from mean position towards the extreme position, kinetic energy goes on decreases and potential energy goes on increases. At certain point of time or displacement, right, kinetic energy becomes equal to potential energy. So we need to find at what distance the kinetic energy becomes equal to potential energy. Now we have the expression for kinetic energy. Ek is equal to half m omega square into a square minus y square. Expression for potential energy, half m omega square y square. So now given, right, so we have Ek is equal to Ep, that means a half m omega square into a square minus y square is equal to half m omega square into y square. So this side get cancels. We have a square minus y square is equal to y square. That implies a square is equal to, right, 2 y square, or y is equal to a square by 2, or y is equal to a by root 2. Right, meter we can take it as, right. So at displacement y is equal to, right, a by root 2. Here the value of a is not given, just a is given. We need to calculate the value of y. So the displacement y is equal to a by root 2 meter. Now we have problem number 7, right. A body is vibrating with simple harmonic motion of amplitude 15 centimeter and frequency, right, 4 hertz. Calculate maximum values of velocity and acceleration. Now, the given problem is a body is vibrating with a simple harmonic motion of amplitude 15 centimeter and frequency 4 hertz. Calculate maximum value of velocity and its acceleration. Now we have given data. So amplitude is given, A is equal to 15 centimeter, that is equal to 0.15 meter. Convert it into meter because this hertz is in SI system. And frequency F is equal to 4 hertz. What we need to calculate, right? Velocity maximum is equal to what? And acceleration maximum is equal to what? Now we know that V maximum is equal to omega into A, and A maximum is equal to omega square into A. Therefore, we need to find omega is equal to what, right? But he has given omega, frequency is given, therefore omega is equal to 2 pi f, where the value of pi is 3.14. Take the value of pi, it is equal to 3.14 radian in SI system. Now we have velocity maximum is equal to omega into A, that is equal to 2 pi f into A. So V maximum is equal to 2 into 3.14 into 4 into 0.15. You calculate the value that comes in meter per second. Now A maximum is equal to omega square A, that is equal to 4 pi square f square A, that is equal to 4 into 3.14 whole square into 4 square into 0.15. Once again you calculate that value that comes out to be in meter per second square, right? You try to do the calculations, right? Now the calculations will increase. The skill of doing calculations will improve only when you practice it, right? So whenever you practice the problem, then you can able to understand the problem. Then you do one thing, you note down all the problems here on a white paper, then try to solve it individually, right? Then only you can able to understand more about the skill of solving the problem, and that completes your chapter, that is oscillation. And in the next class we will take a competitive part, that is NEET and JEE part of this oscillation. So thank you very much.